Today we are going to do experiment number 8, hydrate formula. Now, a brief introduction to this particular lab. Hydrates are compounds which crystallize out of water. On crystallization out of water, water molecules are attached to the salt, that is the cation in the salt. As a result of which, this bonding, which is very weak, the compound has structure and color, and it appears as crystalline compound. As the bond of water of crystallization is very weak, on gentle heating, all the water molecules can be driven off. As the water molecules are driven off, the compound changes its color from one color to another, or it becomes ash white. And then by determining the loss in water, the amount of the solid anhydrate left, that is the compound without any water molecule, if we can determine the moles of the anhydrate and the moles of the water, and then compare the mole ratio, and you can get the formula of the compound. That is the brief introduction to this particular experiment. Now, I'm going to go and demonstrate this experiment for you. It's a short experiment, and so we can do it quickly. Only thing is, you should know all the definitions that are to be done. What is an hydrate? Anhydrate, water of crystallization. How many waters of crystallization? And how do you name the compound? Those are some important points that one needs to do. Most of the introduction that I have done is shown over here. And so I'm going straight to the procedure. It says that obtain a weighed amount of copper sulfate hydrate, say 30 grams, place in a 100 ml beaker, heat the compound with a Bunsen burner till all the water is driven up. You can verify this by pre-weighing the beaker while heating with the weight. When the weight stops declining, you have removed all the water. So let's go and do it. So here is a beaker. We can get a 100 ml beaker, and then go to the chemicals. We add copper sulfate. I'm not going to add 30 ml or so. I'm just going to add some small amount, as I'm just demonstrating this experiment in order for you to see how it works. And then there. Now you can see the compound is blue in color. And so now I'm going to get my Bunsen burner and heat the compound. So before I heat the compound, we have to, of course, get a balance. So get an electronic balance, and then, or we can just click on it and ask it to show the sample weight. Even if you don't want the balance, then I got the sample weight, record the sample weight. Then I'm going to heat it using a Bunsen burner, and I'm going to heat it till all the blue color vanishes, and you can see the water is evaporating from the crystal. Why does the water evaporate? Because the bond of water of crystallization is very weak, and therefore it gets removed on heating. So not a very high amount of energy is required to break it. So once all the water stops coming, and you can see that when all the water is gone, you have the initial weight of the sample, and just you can see the sample weight goes on decreasing. At one point, you will see at this point, you see there is no change in mass. So at that time, we know that the compound has lost all its weight. And so now you can go to the observation table, you put the initial weight, the final weight, the weight of the water driven. Initial weight, take away the final weight, will give you the weight of the water driven. Then what you have to do is find the moles of water, mass of the water divided by the gram molecular mass of the water. Same thing, moles of the final weight divided by the molar mass of copper sulfate. Then to get the X number of water molecules, that is X, where X is the number of water molecules as hydrate, You just divide the moles of the water by the moles of the copper sulfate, anhydrate copper sulfate, and write the formula down. And with that, the experiment is over. I'm going to stop the share and end the meeting.